Hello everyone, welcome to a regular session of API review at an irregularly scheduled time. Yes. Once again, we have a whole big pile of red. We won't finish it all today because it includes a very long thing, but we're going to try with some short things. Or Emo at least is going to watch a clock and tell us when we've exceeded the amount of time we're willing to spend on these short things. So, all right, optimize service collection descriptor extensions triad 44728.
Okay, I can speak to this one. So when we're building up the service collection is the thing that holds all the dependency injection service descriptors. When we're building this up, we have to loop over each one. We have to loop over the collection each time we're adding and building things, because we have to make sure that it hasn't already been added to the collection, and so it basically becomes like a big old n squared operation. And so some of these APIs is to optimize it so we can just, because the internal collection, we don't have to loop over it each time internally. So if we had an API for try add service descriptor or try add enumerable or try replace, the collection can optimize this and not have to make one, the virtual calls to the interface, and then two, have to loop over the whole collection each time we're adding things.
All right.
And so a thing that isn't shown on here is that service collection implements service collection because everything in extensions has an interface.
Yeah.
And so part of this proposal, and then service collection is not in the abstractions package. So part of this proposal is moving the class service collection into the abstractions library, and then adding these new methods on it. And so our implementation that takes iService collection will check for is this a service collection? Is this iService collection a service collection? And if so, it'll call directly into these optimized methods. If not, it'll just keep doing what it's doing today and implement the whole thing. So
do these have the same names as extension methods? Like, are these the exact same names?
As extension methods on iService collection or on collection?
Yeah, iService collection. Like triad enumerable?
They do have the same names, but those are on iService collection, not service collection.
And that's not an issue. It'll just prefer the concrete when it's,
Right, if you have a service collection, if your variable is a service collection, the compiler will prefer these new ones over the iService collection extension methods.
Okay, so the optimization is coming from the fact that you can make a real implementation of triad instead of the extension method implementation of triad. Yes?
Correct.
Okay, because if it internally is implemented as it has to look at every element, it's still n squared. You're just saying that by knowing that you're trying to do the operation triad, which is early aborting, you can save yourself some work.
Optimize dictionary instead of a list, and then do cool stuff.
Okay. Because I was like, I don't see how this is going to help because you're doing the exact same work, but it's because you get to express the operation you want to do instead of doing it using existing surface area.
There's one more thing. Since there is an interface, there is an implementation. There are a couple implementations, not as many as it isn't widely spread implemented. But if you scroll to the bottom, you'll see there are a couple of third-party. Well, there's one third-party DI container that actually implements the interface on their container builder. So Ben suggested we do a DIM for Net Core 3 and up. Instead of putting it on the concrete type, we could put it on both. But yeah, this is one thing to consider.
So what is the interface changes? Because you only had an actual type of members, right?
Or scroll down, scroll to the bottom, but the second last.
I was gonna say, what am I looking for?
Right before this comment has one comment that has the actual right here. Yeah, right there.
What exactly does the DIM bias?
It's not a runtime breaking change, right? Otherwise,
No.
runtime breaking change.
I mean, what is this bias at all?
It's what David just said about third-party implementations of iService collection being able to do this optimization. The other thing might be making service collection virtual, but then you can't do it on like existing types.
It's so third parties can actually override this.
Right.
Yeah. So if you hit the no, it's not is this type, and you're calling it from the interface, that they can intercept the method and replace it.
Yeah, this is weird. So like in this case, you want the extension methods to always call through to the interface unless it's the default interface implementation. So you'd want to be calling something other than the extension methods. But yeah, anyway.
Well, I think it's that anybody who recompiled would get the interface call. They would see the interface dispatch instead of the extension method. So the extension method's now dead.
right?
I mean,
Exactly.
it gets called as
Good point.
the fallback implementation, and it has to stay because if somebody who was compiled against the old definition, they would still be targeting it. But I don't know, Hemo, is this where you want to start trying to add dims and seeing what explodes with the world?
I mean, I have to admit that I kind of feel like Eric, like I don't think it buys us that much. I would probably go down the other path. I would just introduce them as virtual in the service collection if we really wanted to implement third party, or if you want to support third parties doing something, and then I would just say if you want the better perf, you have to change the base type you're using.
Yeah.
I mean, the other option is just introduce an abstract base class in between, right? Like introduce a service collection base. I'm sure we don't like the base suffix, but introduce a service collection base. Our service collection derives from that. That has the triad, try enumerable, try replace, etc.
Right. Yep. That also.
So in the existing case, right, David, you said they were adding the iService collection interface to their built-in like type. So then you might run into multiple inheritance problems if you had like a base class.
But you can just wrap, like if you
could, yeah. I mean, that is an option.
I think Fowler's on hold. And he's back.
Back. I prefer the concrete type. The interface thing is interesting. It has a few warts. Triad actually doesn't return a bool on the extension methods. I'm actually not sure it would just bind the new one. I'm actually not sure what would happen. If you have an interface definition that has a different signature to the one that is an extension method, but they differ on return type, what does it do?
You don't have to
Return
use
type.
extension methods for these, right? Like it would
No.
be nice.
So imagine I had a triad that matched the signature of my interface method, but had a different return type. Like, what does that even do in the compiler? Would it be ambiguous?
No, the compiler does not look at return types, right? So the compiler will bind the call if now the instance method is applicable.
Is
it will
more
prefer
valid.
that
I
one.
see.
And then you
Got
just
it.
get a compiler error that says, sorry, you can't pass the type depending on what you do.
The
Interesting.
one exception, but I'd have to go back and look at what the order of resolution is if it's being used as a lambda and it's trying to figure out what the generic inference to hit and if it could hit both func and action.
Interesting.
Or if it's two different return types and it could be it's like I can't figure out which func to call.
Okay.
But basically it means that you're setting yourself up for failure.
So how do they differ? Like it looks like they have the same signature except for the
current tries are all void, which means they're not tries.
Oh.
Let's not talk about that.
Well, but that's probably fine, right? Because if the current one is void, then you couldn't have used it anywhere anyway, right?
Yes,
so now
but
the fact that it returns true
a
is
dim
fine.
also can't say what the implementation is. Because it would be call this and then manifest an answer, which it won't know. So the dim would have to go replace all of the logic and figure out if it's true or false. Which is fine. I'm just saying it's not as simple as was proposed because the try methods aren't actually tries.
Well, what do they currently do there? Like, I mean, presumably they always return true, always false, or something, right?
No, they're void. And in Ben's sample, he assumed they were tries.
Oh, he assumed they would return true or false. I see. I see. Well, but that's regardless of dims, right? That's just that the existing API surface is not the same as the one we want, right?
Right. Exactly.
Yeah.
Yeah, I mean, yeah, it depends on what you guys think. Like, my personal opinion is I would just do them on the service collection for now. Like, I would not touch the interface at all. And if somebody is asking for that, then we would say, well, why can't you extend the other one? And then we can have the conversation of making it virtual, maybe.
I love that.
Yeah.
Do we make a bunch of stuff virtual on it, like clear and contains? Like all the
Only,
existing
only
stuff?
if they ask. Only if they ask.
Okay.
I mean, the other
I mean,
answer is you
technically,
come up with an iService collection 2 that adds these 4 operations. I'm just like
that,
No, I know.
that's what we would do in the BCL if we cared about the scenario and DIMs hadn't been
No, yeah.
invented yet, or we were still afraid to use them.
But we have dims.
Yeah, we're still afraid to use them.
Especially for these, because these are all net standard libraries, right? Extensions like is maybe the one place where we would want to use them, but they're all net standard, so it's like, well, we can't use them anywhere, right?
I see. Yeah, that's another complication. If this thing targets net standard 2, then I would certainly not use DIMs.
Exactly.
Right.
So-
Yeah, that's why I've never liked DIMs in extensions to begin, because they're all net standard.
It's the one place
I
that
mean,
I feel comfortable adding them, and it's the one place that we with technology can't add them. So
Right.
I mean, you could do what Ben is suggesting, right? Which is you just have a net core app 3.1 output that has the DIM and the net standard 2 doesn't have it, right? But like at that point, if most consumers are net standard 2, then who's doing the DIMs, right? So that's I mean, it would only buy people something that actually are on net core app 3.1 or higher, which I don't know. Like if you have a third-party implementation, chances are it's a library, and chances are it targets net standard 2. So
How much does this actually affect startup performance?
Enough that
is
we
it-
want to change it. It does. It's measured.
But are you affecting startup performance in core or net standard apps, like full framework apps?
Core? We only measured core. We don't care about full framework that much.
So the fact that you just said we don't care about full framework that much makes me think that it would actually be okay to have full framework have the older, slower behavior and just say, you know what, core gets the new hotness, end of story.
Yeah, but why fork it if we can make an easy change to just put this type in the abstraction and then just add these methods?
Oh, I'm saying that if you
Oh, for dims.
if you did have a compelling reason to introduce a dim, like
I see. Got
sure,
it.
you could fork the API there.
Yeah, exactly. But I kind of prefer the either the virtual thing where we make the whole thing virtual, or we just don't do it yet and we do this first, and then make it virtual after. Because everyone complains about it. I don't know.
yeah, I mean, I certainly
keep in
can't
mind,
advise
making
on your.
things virtual can break things too. It's rare, but it can happen. So we probably don't care enough. So I would say do it when you absolutely have to.
I mean, what about the introducing a new abstract base class here instead
That
of
one
moving-
is easier because we can always introduce a type when we have to, right? I mean, yeah, I mean, it kind of depends on, I mean, at that point, I think you're talking about a slightly different feature though, right? Right now, you're just talking about prior optimization. I think what you're asking for is how can we make it so that people can derive from some abstract base type to have their own container and have different behavior, but
what I'm really asking for is to fix the interface from now on, kind of thing, right? Like we shipped an interface and then we're struggling adding new methods because we can't put it on a new interface. So we quote unquote fix the interface by introducing a base class instead, and now we can add methods every day we want.
So there's nothing wrong with that. I think the problem in practice is that once you have an interface, if that is the thing that is always passed around, then changing, like adding a new type will not buy you much, because unless everybody passes that type around now, they will still talk with the old one, right?
Exactly.
So,
but that's the same problem. But that's the exact same problem with having the concrete service collection moving to abstractions.
Well, it depends on who the receiver is, right? Like if the scenario generally is you just try the downcast, and if it succeeds, you call those methods, then the type you're passing around no longer matters anyway, right?
Yeah, and why do you need to move it to abstractions?
Because that's where the extensions are, and the extensions have to check for the actual concrete type and then do the optimize
Okay,
call.
so the it's because that's where you need the is. So if you added, if you were adding right now the service collection base, which is probably the best name for something to add after the fact, then that would go in abstractions and you would leave service collection where it is. So it actually does affect whether or not you feel like you need to move a type right now.
Yep.
Plus, it also has all abstract, add, clear, all the existing methods, right? So if somebody really doesn't want our service collection, the concrete one, they want to extend their own, now they have a base class that they can just extend with no behavior.
But to be fair, the thing you're fixing there are these triads, right?
Yes, we want to fix the triads, right? But we're also running into the problem that we can't add new methods to this interface.
But to be fair, like yes, that is true. But all the calls have to downcast anyway, because we're never gonna pass around the base anyway. Everything that today hangs off of the interface, all the extension methods.
Right. And so every problem with service collection base approach is also a problem with the concrete service collection approach.
But you don't have to add a type, is the benefit.
But you have to move a type. You have to
That's easy, right?
It's easy, so you have to move a type.
I mean, moving types is worse than adding types.
Really?
Yeah, but also B is if somebody doesn't want our implementation, they can just derive from service collection base and do their whole own implementation.
Okay, but yeah, sure.
You get the benefit of having the interface, if you will, but you're an abstract class, right?
Virtual calls, it's fine.
So, I mean, I would say make that a separate issue, and then we can talk about that if you want.
What are we going to do with this issue, though, then? Like, we can't do anything with this issue without making that decision.
I mean, it depends on what scenario you're trying to solve, right? I think I mean, you might be right that we will only ship one of them, but like there seem to be like different problem spaces, right? One of them is really about optimizing lookups, and the other one is really about making it more flexible for potential different implementation of the service collection, right? And so they you know, they're not the same solution or problem space wise, right?
No. So the original problem is we want to optimize lookups.
Right.
And then a sub problem of that problem is that we can't add methods to an interface.
Right. Which is why the BCL guidelines are don't add interfaces. It's add abstract classes.
Right.
It's this exact problem.
But it's wrong. Because now we have dims. Boom.
Except we don't, because net standard.
Not here, sure. But honestly, this is for perf. I think the virtual is added niceness because it lets people extend for the 5 people that derive from the interface and like change the implementation.
So what we're saying is for this one, move the service collection class, log a new issue to say, let's add a base class. And then in that issue, if we approve it for 6.0, we'll say, oh, let's move service collection back.
No. We'll keep it where it was, and then just add virtual to service collection.
Meaning you want service collection to be the new base class?
It would derive from the base.
Then you wouldn't need virtual.
Yeah, I mean you would change the existing methods to be
Sorry.
overrides.
Overrides, that's it.
Okay. And you can go so far as to make them sealed overrides.
Sealed overrides.
If you want, since they're currently non-virtual methods on a non-sealed class. But
right.
But if we just introduce the base class here with these 4 new methods on it, right? It implements iService collection, adds these 4 new methods on it, all the problems are solved. Yes, it's a more scope. It's solving more scope than what needs to be done to solve this exact problem, but it sets us up in the future for the next time we want to add some new method.
10 years from now, I'll be here. I'm fine either way. I don't have any pushback.
I mean, I would generally say like I don't see anything wrong with that. It's just that unless you really design for extensibility and customization, I'm not convinced that just adding a base type with some virtuals will solve the problem, because it's very rarely the case that you can just make things virtual and then say, yeah, people can derive from it and override it, because it really highly depends on how these methods work and what
And
the
that's not
interplays
that's
are
not
and
what
so
I'm
they write the
proposing.
right things.
But that's not what I'm proposing here. I'm proposing new abstract class, service collection base, implements iService collection, and all the methods iService collection has is abstract. And then it also adds 4 new abstract methods, which are these 4. Then service collection, this class, inherits from service collection base, does all the stuff it does today, plus these 4 methods.
Yeah. I mean, I'd hope that you can make, add virtual instead of override, given that triad and add have usually a well-defined relationship. So it doesn't need to be 100% abstract.
Well, in order to add value, it can't be, right? The whole point is that you add new virtuals, not new abstract.
Right.
But since it's a new abstract class.
Right. I mean, I think the problem in practice is, so let's say you add a new abstract type, right? So you have one shot to add abstracts to it. Next time you want to add a method, you can only add it as a virtual, right? And so so in that sense, the proof is in the pudding, in the sense that the next time you want to add something to it, can be actually express them as virtuals, not as abstracts, right?
That's fine. That's every abstract class in the world gets that.
Right. But that's what I'm saying. Like, to me, the success of that is kind of, we can do it. It just depends on whether it's actually adding value or not.
Right. Because often we end up having the new virtual be virtual throw, I'm sorry, no one implemented me.
Right.
It sounds like you're arguing for never introduce abstract classes.
No. It's simply
it's kind of irrelevant to this.
It's just, I think the statement here is, you're saying adding the abstract class now helps solve the problem for the next time, but unless we actually have an idea of what the next time thing might be, we wouldn't be able to express it. Like if it's the array versus span problem, right? You're like, oh, we have a collection, it works on arrays and enumerables, and we're great. And then we added this new thing called span. It's like, well, we can, in some cases, we can make up how this would have worked, and in other cases, we have to say, throw, I'm sorry, no one wrote this, because we can't figure out how to express this in terms of the existing API. So the abstract class is the only extensible method, but it doesn't always work. So it's adding the class now won't necessarily help for the next time, is the statement. It might, in which case great, but it might not.
It fixes the interface problem that we have today.
Yeah, and for this particular thing, if you did it, you could do it without moving service collection, because your is test to call the Boolean triad instead of the void triad would be from the same layer that the interface is already in.
But to be frank, this type should be in the abstraction assembly. It should never have been in the actual core assembly.
Fair enough.
I have no idea why we did that in the first place. We're crazy.
Okay.
All right.
So base class. New methods.
I mean, I still vote for it, but
virtual calls.
I don't vote for virtual calls.
I mean, if you're adding the base class, some things need to be virtual.
If we're adding the base class, everything's abstract, in my opinion.
Sorry, but that means that the caller is doing a virtual call. Like the JIT will write down that it's a virtual call instead of a direct call.
We can't seal service collection.
I assume what David was saying was like making some of these methods virtual.
Oh no, just the calls after the is cast are now virtual instead of being concrete. But I mean, whatever. Still faster than doing n squared lookup. So.
Okay, so are we needs working this to add the class? And then we'll approve it with the new class, probably?
I still want to move the type.
Can you move it? Propose it as well. Include
that. Okay. Okay, so move type, add new base, and then derive the collection from the new base. Make these overrides.
I mean,
Cool.
if we're gonna move the class, I'm fine with just moving the class on this one.
Okay.
If we need the new base, then that can be a new issue. Like
Okay.
I was trying to avoid moving the class, to honestly.
Okay.
Yeah, I mean the most significant thing it breaks is runtime. You call get type full name, that will give a different answer now, and that may, depending on how you're doing type matching, that may break things. The runtime thing will look it up, but we do have to for the rest of time carry the type forward in the old assembly. So
I mean, honestly, type forwarding is not that bad because if
No,
you
no,
compile for net standard, every type is somewhere where
right.
else
I'm just
where
saying
you looked at
it's
it and
not
you have to-
it's not a one and done. It is a perpetual cost.
No, it is.
This one's fine, I think.
Cost, but like
Yeah.
if both assemblies already exist, it's fine, right?
Yeah.
Like we have done that before.
And you're
relatively
moving
easily.
toward object, which is the acceptable direction.
Exactly. Yeah. Yep.
Please don't put it in system right there.
Yes. But if he cracked the library in two and this became the new library depended on this one, that's moving it out, which will break assembly
Yeah,
load
out
scenarios.
doesn't work.
You can only
Can
move it in.
Yeah.
So. Okay, so approved?
Ship
And
it.
if you want to make it a new issue, sure. I mean, I would have just updated the decision now, but
Huh? That's all I'm doing?
Yeah,
no,
if
I
we
meant like if we want to do all the changes that Eric said, then I think we should bump it back as needs work, update the proposal of the new type, the new location, and then we approve that one.
I think the new type got yanked. Eric said he didn't care to add the new base class once David wants to move the assembly anyway.
Oh, I see. I missed that part. Okay, in that case, yeah.
yeah, the new base class would be a new issue unrelated to this.
All right, and that's easy.
All right, Emo, technically we're already past the time for the two issues. I assume we're just going to steal time from Tanner?
Yeah, I think we probably should we should approve the notes one because that's hopefully just we all nod and say yes.
Okay.
So that should be.
All right. 519037, rename system text JSON node to system text JSON nodes.
Yeah, this should have just been an email that we said yes to.
Yeah, I mean, just to give some context, so basically somebody wrote a VB sample where they for each over a bunch of stuff and they named the loop variable node. And apparently VB has this funky behavior where if you use type inference there, where you don't explicitly declare it, that will declare it unless the compiler is able to resolve it against something else. And so apparently, because we have a node namespace, the local loop variable node is no longer declared, and instead it just binds to the namespace, which of course no longer compiles. And so that's some weirdness in VB, and normally I would not feel super obligated to honor that, but the problem is it's a lot of VB code, of course, that uses the term node, so it's a lot of code that we broke with that. And then secondly, like we just generally don't name namespace names with singular names if they likely result clash with class names, because that's almost always a problem. So we should have just named it something else. I mean, nodes is fine to me. I mean, I'm not entirely in love with nodes either, but
I mean, the
nodes
same
is not
problem
likely to
can
collapse.
exist, right? If there's some place in VB that they can have a local that was a collection of nodes of some sort, they would name it nodes. It seems less
Right.
likely than node, but if we care
No, I mean,
about
like I think in
VB magic binding, that's still a little iffy.
Yeah, I mean, that's why I'm saying I don't feel obligated to like make VB happy, because it seems the semantics are in a way where you can't like. But I think there's just the sheer probability of conflict, right? If you introduce something like node that a lot of people will likely use, then it's bad. If somebody names their local variable nodes, sorry, like you're still broken by this. So you have to like write some change your code, but that's fine. We're not shooting for 100%, right? We're shooting for something reasonable.
Yeah, so I'm fine with the yes. Any objections?
Node seems reasonable.
Counter proposals? Going once? Going twice? Sold.
But we can't put asterisks in the namespace name.
It's the new language feature, C# 10.
Markdown supported identifiers? Oh my god.
All right, scary issue. Adding a rough draft of the MVP for APIs for generic math, which involves a class diagram that looks like it cycles on itself.
Also like the quotes around minimum viable product.
Yeah.
You can read it in so many ways. Is it minimal, or is it viable, or is it a product?
Maybe it's a product.
There's no cycles. It's just the UML diagram does not lay it itself out very nicely.
Fair enough.
Yeah.
And the arrows go the opposite direction of how I think.
Regardless, we know it's the MVP tammer. So yeah.
Okay, so C# is going to be adding static abstracts and interfaces in a future version of .NET. This will not be .NET 6, but we are planning on previewing it in .NET 6. One of the main uses for this on the library side is that it will enable you to write generic math finally. So you'll be able to do things like T plus T, where you've never been able to do that before. There's a couple scenarios listed. If you scroll down a little bit, Jeremy. Actually, it might be easier if you just look at the Markdown README file here.
Where's here?
Chat.
Okay, good. It's a link from chat.
Yep.
I was gonna say that would require that I figure out a way to share the chat that is conducive to being on the internet. Okay.
So today, if you want to support effectively generic math, you have to do something like this scalar add method, which we actually use in vector of t, where you do if type of t equals type of x, then do your conversions, do the addition, and the JIT compiles this all down correctly. Scroll down a little bit more. With the generic math proposal, we'll be able to define some core interfaces such as iaddable and expose the static abstract operator plus method. And then scalar add gets simplified to effectively just this code here. And for any T we want to support, you now have this effectively 2 lines of code. If you were truly generic, you wouldn't need the throw for unsupported, but vector of T is somewhat special and restricted, so we'd still have that check there. Likewise, let's say that you wanted to start calculating standard deviation. You might be able to do something like enumerable average and enumerable sum, but that's not so trivial to, and that allows you to implement it over a specific type like int. But if you want to support all types, that's not really possible today without doing all those type of checks, and then you're limited to the concrete types you actually supported. With the interfaces here, we'll be able to now define a get standard deviation over t, where t is I number. And scroll down a little bit more. And so now you could actually implement a method similarly to this, where you effectively take your t, you convert it to double, and compute the sum. And so now it's generically supporting any t that's a number, and not just a specific subset of t.
Why does the average of, like, if you have a vector 2 by 2 that is a number, let's just ignore whether or not that even or doesn't make sense. You have a complex. You make a complex number type. Why would average shouldn't be a double?
So complex is not a number type. Complex is, and we'll get to this a little bit later, but number is more a scalar number rather than any number. Once you start getting into composed types, like complex, which is actually 2 parts that represent a number, you can't represent them via the same interface. And so complex would have to be a separate. It would have to be supported in a different way.
Okay, because complex numbers are addable, subtractable, multipliable, and dividable. They just don't average to a double.
Right.
And if you make it feels like if you made uh, you know big decimal, that like double would be a loss of precision that you perhaps
Right,
wouldn't want
and
to do.
some of this is just a little simple scenario, not necessarily a real world representation.
Okay.
It's more to show something that you could do with these functions. The interfaces that I've defined here as the representation for the scenario aren't even the real
Okay.
interfaces
So
that I've defined further
this
down.
double isn't necessarily double. It's complex intermediate data holding type.
Yes.
Okay. Which we call double. Okay.
Yeah.
Thank you.
And so a lot of the design here has been influenced by Swift, which is probably the closest object-oriented language that's exposed similar things. They don't use traits; they use protocols, which are effectively interfaces, at least for the purposes of this discussion. And so they are a kind of close parody to what C# somewhat needs to do. There's also influence from Rust and Haskell and other languages, but they more often use traits and duck typing. And so while there is some influence from them, they don't necessarily translate well to what we're able to do here with static abstracts and interfaces. There's also there's some concern from the runtime side on how the number of interfaces we expose here will impact startup. It's possible that exposing all of these could add 5 to 10 milliseconds of startup, which is a small amount compared to the overall core CLR startup time, which is already over 100 milliseconds. But it is still a concern, and it's something that that may impact exactly what we expose when we do ship this. What I've proposed here is what I believe to be the actual minimal and correct product, which is all the interfaces that allow you to be extensible for other libraries to define their own iNumber types, and while still allowing us to expose no more than what we actually think is effectively the core types. And so then we get into the actual interfaces here. And the first one doesn't necessarily apply to numbers itself, but it's effectively the sibling to iFormatable. It's iParsable. It takes and it just exposes parse and try-parse, which return tself and take string, and then ispan parsable, which mirrors ispan formatable, which takes a read-only span of char and returns tself. And so that's kind of the simplest variant of static abstracts and what it's going to enable, and it kind of extends from there.
I'm just slightly curious. Do the current compilers understand the cycle of where tself, like interface iParsable of tself, where tself is iParsable of tself? Do they currently accept the cycle, or is that a feature they had to add for this?
No, they accept the cycle. The cycle will also be specially recognized in newer compilers to allow operators where the type is not iParsable but tself instead.
Fair enough, because just trying to think it through. It's like, do I meet the constraint? Can I write this here? Well, I don't know. I have to apply the interface, and then but I can't do that unless I know it meets the constraint. So
they already work with the curiously recursive template pattern today. They just don't specially recognize it, and they will specially recognize it for some things in the future.
Cool. Thank you.
And it's possible C# may have a slight variant on how the CRTP is defined. They might end up saying where tself is sub of this. They might say iParsable this tself. They're still deciding on that, but this is the simplest and what works today.
Fair enough.
And for iParsable in particular, these do explicitly do not expose the variants that take number style, because the number styles doesn't apply to all parsable types. It only applies to number parsable types.
Yeah, and so this is actual proposal now, right?
Yes,
Okay.
yes, this is actual proposal. And a lot of these are still rough draft, so input on names and things where appropriate is appreciated, but there is a lot to get through, so we should keep that in mind while we try to go through it. After the one thing that Steven brought up is we might, given that this is a first time thing, we might just be able to expose iSpan parsable and say everyone must expose span variants. So we could cut one interface out that way. I exposed it as 2 here for consistency. Then we get on to I-equatable and I-comparable operators. These ones could just be named I-equatable, given that it takes 2 generic types, and then it wouldn't conflict with the existing I-equatable. We can't, and we do want to expose both T-self and T-other, because there are types like complex where T-other isn't the same as T-self. It might be, for example, the scalar type that's represented under the covers, which is done for efficiency purposes because you may not want to allocate. Such as in complex, it can completely ignore the imaginary part and simplify the actual computation there. And there's a number of types, especially when you get into system numerics, where we follow similar principles. We likewise have I-comparable operators. It could likewise just be called I-comparable T-self T-other, and it wouldn't conflict. It enforces I-equatable operators to also be defined, which is being done because less than or equal to and greater than or equal to imply equality as well. Likewise, it enforces you implementing the non-generic I-comparable. The I-comparable of T does not actually enforce that today. I didn't have a strong preference on that one.
Yeah, I was just looking up. I think our current naming of LHS and RHS are left and right.
Yeah,
So
I used LHS, RHS, and left and right a bit interchangeably between here. I assume that they'll all be left and right in practice because that's our actual names.
Does this imply that if I wanted to have T-other on the left and T-self on the right, I'd actually get a compiler error?
Yes. There is no expression of commutativity here. There may be some way for the compiler or tooling to represent that, such as using attributes in the future, but today that is not expressible. It adds a lot of complexity. It is not always guaranteed. And so the recommendation is just always put your T-other type on the right-hand side.
Yeah, the recommendation in the guidelines is T-other should always be T-self. That's what we said for all of these math-like operators, is don't do this. Just use let a implicit conversion or something be what ends up making this function. But if it's actually important for things like complex to occasionally do this in a way that needs to be expressible with generic, then this is the only way that we can do it.
It's also important for like matrix when you get into like multiplication, because matrix times scalar is a valid operation, and that is
fair enough. Yeah, I meant specifically for equal and not equal here. Yeah. The answer, what we put in the guidelines, is you're setting yourself up for failure because of you can't necessarily swap which thing goes on the equals, and that makes things really hard to reason about.
Yeah.
But yeah, if we need it to be expressed this way, then it's a start. I was just slightly wondering, maybe we would then also want to, unless if we have a purpose for it, self-equatable, which just extends this and puts t-self in both slots. But if we don't
I
need it,
think
we don't
that
need
ends
it.
up being just I comparable and I equatable that takes one, and you just call the equals and compare two methods.
Fair enough.
Mostly there's the balance between number of interfaces we expose and core functionality. And so when you're looking at wanting to expose the core functionality to support extensibility for everyone while also exposing the minimum number of interfaces, then T self T other covers that.
So does that mean that you expect people to be able to have different types on left and right? Or is that
Yeah,
the flexibility that you...
there are types like complex which explicitly have both I equatable complex complex and I equatable complex double, because it's an optimization and a fairly critical one in more complex numeric code, being able to cut out the imaginary part. Or when you're doing, for example, scalars, vectors, and tensors, being able to cut out many dimensions in the comparison.
So on these types, where we're doing operators, our strong suggestion is interfaces end in able. So I wonder if we should, if instead of I equatable operators, it should be I operator equatable.
Well, we could also, because it's two generic types, we can also just call it I equatable.
Fair enough. I think that having I equatable of with arity 1 and I equatable with arity 2 being for different concepts feels weird. So
yeah,
that's why my suggestion is just
would,
move operator between the I and the equatable.
Yeah, I would expect an actual equals method if this were called I equatable. Like not operator equals equals, but like a method called EQUALS.
Well, there is one. It's from I equatable T other.
No, I mean one that takes two different parameters as a, yeah.
So anyone want to agree or disagree with moving operator to the left?
I think that's going to come down to when we look at a number of these. Personally, I think I equatable operators read significantly better than I operator equatable, particularly as you look across all operators. And there are types like, for example, I remainder, which there isn't an able name available for it.
I remainable.
I remain able to do things.
Yeah. No, so let's keep going with this. Just see how far it goes.
Yep.
Yeah. Then we get to I additive identity. In particular, I was flip-flopping on whether we needed the concept of I additive identity here because it adds another interface, and I was figuring that it would be good to just expose the identity concept on iNumber itself. But once you start looking at vectors and other types, including things like date, time, and time span, which have logical identities for their operations, it ended up making the most sense for extensibility and correctness to just have I additive identity here.
Why can't you put it on the additive operators?
Because not every so if you put it on iAddable itself, you'd have to consider whether T self T result is correct, and whether or not T result is the correct. So, for example, it would end if you exposed it on iAddable. The only logical thing here is actually returning T other, but that's not always correct. There are places where you might support multiplication where T other isn't doesn't have a correct identity.
But I like the example you gave here with datetime a few lines below, where the additive identity of datetime, I believe, is timespan.0, correct?
Right.
Yeah. It's not a datetime instance, it's a timespan instance.
Okay, I was going to ask, when is the case where self and result aren't the same, and I guess because date times you can't add two date times.
Correct, but you can add a delta to a date time. So the delta type is the additive identity type. So timespan.0 is the additive identity.
Which is, yeah. I mean, it's not actually an additive identity because an additive identity means you have to stay within the same domain, but I can't think of a better name for it. It is the additive identity when t result is t self.
Yeah.
Otherwise, it's just a thing that means zero in the context of the plus operator that's defined similarly, which is not the same as identity because identity means is itself. So
Yeah.
Why do you need the T self at all here? Like, why wouldn't you just implement additive identity of T result?
Because this is a static abstract, and static abstracts must be able to be constrained. And so fundamentally, you have to have a T self that it's constrained onto.
Oh, I see. So that's a fundamental like constraint in the type system, and you want to have static.
Yeah. So basically, anywhere you do a static abstract, you're going to want to have a T self type that represents the type that the call will end up resolving to when it's called.
Gotcha. But basically, I think that's logically why you can't have it on iEditable, because you don't know whether because basically you would implement iAdditive identity for multiple types potentially, or just one, but you don't know which side.
Right, and so the only correct thing you could do there is T other, but that may not be correct because T other might not represent an additive, might not have an additive concept.
But if you put it on iAddable, it absolutely does, because it's the thing that you're using in an additive context.
T other might not have a zero concept.
Fair enough.
You might have a value where there is no T other, in which adding to T self will return the original value of T self, which is why it needs to be a distinct and separate concept.
Fair enough. I mean, again, from a math perspective, that means you're not actually plus, because that's the definition of plus. But
right, but
once T self and T other aren't the same, you're not math anymore. So.
Well, that's not exactly true either, but
fine, you're different math that I didn't feel like studying.
Yeah. Once you start looking at all .NET code, everything that can expose operators, etc., it makes sense to have them logically separate concepts, and that's the real reason why every operator here, well, most operators here are really their own thing, because you have many types where plus exists but subtraction doesn't. You might have cases where multiplication is valid but division is not, right. Where division is valid but remainder is not.
This is new, I think.
Yeah. So some of this code here is going on the assumption that 3 additional proposals that have been put forth to C# Lang are going to happen. They are currently championed. They are going to be taken to LDM by Mads, Alexei, and so it's very likely they will come in. Checked in particular is considered a core concept, which is currently being tracked as, if we don't have this in V1, we will effectively never be able to add it in the future, and it will likely significantly hurt what we do ship. So in particular, one of the proposals is for checked operators. And so this would define a new operator, op addition checked. And if you are in a checked context, either via the compiler switch checked plus, or via an explicit, checked context in C#, this version of the operator would be preferred. Some types, like big integer, would define this as doing the exact same thing as the unchecked operator. But other types like int32 or our own int128 type, which we might expose in the future, and which we would be able to expose now that this concept exists, they would have different behavior, one overflowing, one not.
Okay. And I know it's not exactly the right forum, but checked can't be put as in the method declaration to mean that it applies to the whole body the way unsafe can, right?
Correct.
Okay.
And it would, at least for operators here, the default, if you put it here, then the default context of the method body would become checked.
Okay, so it would basically be adding that at the same time. So,
Yes.
okay.
And
That's fair.
then you've got subtraction that mirrors addition. And then incrementable and decrementable. Likewise, there's a comment here explaining this doesn't inherit addable because other isn't necessarily well defined. Regardless of framework design guidelines, there are languages which use things like plus plus to represent, for example, moving to the next element in enumeration. C++ is one of them, for example. And so incrementable is its own concept that is simply T-self operator T-self. The only reason it's restricted to T-self here is because C# requires both of them to be the same. And it wasn't believed that it's worth relaxing that here.
Do we need different methods for prefix and postfix, or is that out of scope?
That is considered out of scope.
Okay.
Because that's just the language handles that, right?
Right. There's no way
yeah.
for you to define a pre versus postfix.
Okay, I thought C++ allowed it, which is why I was confused.
Yes, C++ does, but IL doesn't actually define it. And the way C# handles it is it just varies the IL it emits to do the pre versus postfix.
Sounds good.
Likewise, you get to multiplicative identity, and then multipliable, and divisible, and then remainder. And of course, the ECMA name for remainder is op modulus, so the behavior may not actually be remainder. Likewise, there is no UBL name, and I didn't have a good alternative here, so it's just remainder.
I'm audible.
Should we consider maybe exposing divrem as a first-class citizen here?
So divrem is a concept that I've considered elsewhere. Min-max is another one that was suggested. For example, min and max could just go on comparable, theoretically. But I didn't put those here today. They're actually on inumber instead. We could move those if desired.
Okay.
And then once you've said that, because this is obviously entirely new stuff and can't ever interact with net standard, is like comparable. Would that make sense to have a static dim for max?
None.
So dims are going to be required for effectively V2 of whatever we ship. It is still to be determined if they will be in V1. They're required for V2, that way we can actually ship changes to inumber, for example, without having to ship an inumber 2 or an inumber 3. But whether or not they'll be in V1 is still effectively to be determined.
But
Yeah,
I guess
I
your
assume-
proposal still isn't to change any existing interfaces, right? They are all net new.
And the only real benefit here is there's some methods which we could simplify the implementation of if dims are in V1.
Right. Well, because
Otherwise,
it's like the min, doing the max of 2 and min of 2 on comparable. It's like, well, I'll just call the existing operator you told me to define. But if you can do better than that for some reason, then override it.
But how does that work with things like not a number?
Yeah, there are edge cases that have to be considered, particularly with floating points. There is a correct default behavior there, though, and
Okay.
it should end up doing the right thing with just the standard.
Or
Because I thought the reason that because I was actually going to ask about this earlier, but I thought the reason that you hadn't done it is because you can't guarantee correct results with any default implementation.
right, but things like double.max, like double would just replace the dim with calling math.max of double.
Right. So
Yes, but it now requires you to to not only implement an interface, but also override the interface's default behaviors in order to get correct behavior, which is a bit weird.
If you're double, or have equally
Yeah,
weird states like double.
But that also
There's-
means that it affects our ability to add new default interface methods in the future, because we need to make sure that we don't. We need to make sure that every single thing that we add is correct for all possible types T.
There
Correct.
are other core concepts here, such as floating point, that allow you to do an appropriate check and do the right thing for those types.
Okay.
So there are correct things we can do here, but some of those are, I think, out of scope for the discussion here.
Yep.
Okay, sure.
iNegatable is the next one. There's a question of whether the unary plus operator should be its own, or if we should even expose unary plus at all. Unary plus is, for most purposes, always going to be return self, just return the identity. It's very good for helping with maintainability of your own code, because you're able to align columns with plus versus minus and more easily see that this literal is intended to be positive. I didn't have a strong preference here. I just put it on iNegatable because that's where the parity exists, and I wasn't able to come up with a good name here.
So, out of curiosity, could you actually make them virtual and say return self or return value? Would that actually be possible?
That would be if DIMs are supported in V1.
Okay.
But it's not actually return value, right? Because plus, while plus on ulong is return value, plus on long is complicated.
You're thinking absolute value, which is different from identity value.
Sorry, isn't
Unary
unary plus on the absolute value?
No, the plus is return self.
Okay.
If you have a negative value, it will return the negative value back. It does not invert.
Why do we have that operator in this language?
Because it allows you to align columns.
Yeah.
Does the compiler actually, is there actually an operator that gets called?
Yep.
I thought the compiler just didn't
Yep.
do anything. Oh,
you
wow.
you
Okay.
can you can define your
Define
own
one, it will
operator,
get called.
and you can make
Awesome.
it do absolute value if you wanted to. You could also make it, connect to GitHub and download .NET Runtime if you really want to.
So I wrote in chat kind of tongue in cheek, but it's like, well, I arithmetic unary operators,
Mhm.
unary positive, unary negative.
If we zoom out a little bit, I think naming convention wise, I would actually be in favor of having a unified convention that basically has the name operator somewhere in it, because as you said earlier, the bull names become weird, and it seems like right now we have this weird split where some are and some aren't.
Yeah.
I would just pick, a convention that we can sustain for all of them.
Yeah, and
Mhm.
I think in my opinion, the simplest thing that follows that also reads well is, I think, addition operators,
Right.
basically using the ECMA name, or common subset name, and then operators at the end.
Yeah.
So I shift operators, I negation operator, I
That's fair.
remainder operator.
Yeah, it would also. Some might also still be hard to define, like the arithmetic identity or something you had earlier, but.
But at least the
for
ones that are
operators,
just
it
defining operators, yeah.
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 It seems like a desirable thing.
For
And Tanner, did you so bitwise, they are not required by the compiler to be co-implemented, right? I can only define and not or, right?
yes, but just like with less than versus less than or equals, I've not been able to think of any scenario where you only want one. And so I strongly believe, at least for bitwise, that and, or, and XOR should be together. I'm not necessarily convinced on the complement operator. That one maybe should be complement operators or something. But for now, I've put them all together.
Yeah, I mean, it makes sense to me if you think of it from a, what makes sense numerical wise. If you think of those as there's syntactic sugar that the compiler may be able to call, and can you express that? Like as you said earlier, like, iterators in C++ are, they're not numbers by any stretch, right? They just, abuse the operators to make them more readable, right? And so if you want to support that, the only fear that I have is that we find ourselves in a world where we shipped an interface and later on said, oh, great, can we extract or can we split up the operators, right? Then becomes a bit of a mess.
I think that ends up becoming we expose I and operator, and I bitwise operators ends up inheriting from it.
Mm-hmm. Yeah, that's what I mean by mess.
Yeah.
It's I guess my question is, would V2 look any different from how we would have done it in V1? And the answer is no, because we believe just dims all the other stuff, we'll just patch it up. Then I think it's fine to be more
and that's what
opportunistic.
Once we have a functioning runtime prototype, I'll be doing community outreach to help validate that these are correct and work for for any third party for any interested third parties. There's some key ones that we're looking at. And so we'll be doing that to help vet that this is correct. And so this represents what I believe to be currently correct, but that of course may change between when we actually ship V1.
So in FDG we have an operator overload table which talks about the symbol, the metadata name, and our common friendly name. And I see that in here we wrote all the assignment operators. Can you remind me how C# works right now with operator or with assignment operator overloading?
You can't do them.
Yeah, C# will implicitly do it as x equals x plus y, and it will double evaluate x.
Yeah.
Okay. So
you can't define them basically.
But does IL allow it, and
yes,
like C++
IL
CLI intercepts it?
Yep, and C# will not respect them. So for most, and F# doesn't allow them either. So for most purposes outside of like C++ CLI, you won't encounter them. You won't be able to define them. And it's not something that I think needs to be pushed through C# LDM to allow, unlike
C++
the checked operators.
also supports instance operators, which C# also doesn't respect. They all have to be static. So interoperating with C++ is basically impossible.
Yeah. I guess one piece of feedback I have here on the bitwise operators too is like I'm really struggling to find a scenario where T-self and T-other would be different, given that we're talking about binary operators, meaning you need T-self and T-other to have equivalent bitwise representation.
So there are cases where those exist for vector. I think it was a mistake exposing them. And I wasn't here when I wasn't even at Microsoft when we actually reviewed those.
So like a vector of T and vector of U, because they're both, say, 128 bits?
Yep.
Okay.
That it actually happens for float in int. But for all of these, regardless of framework design guideline, I went with what does C# allow here? And if it allows T-self, T-other, and T-result to differ, then the interface will allow it to support other languages, to support types that may differ. And to avoid the scenario of we ship T-self, T-result, or T-self, just T-self, and then in V2 we go, oh no, this didn't expose everything, and we've got to expose a lower base interface.
Sure, so better to make it too broad than too narrow, because you can always just not take advantage of the breadth.
Right.
Okay.
And the worst case here is a user has to type T-self 3 times.
Oh no.
Which isn't terrible.
Yeah. Okay.
Well,
And
You'd say
as
that,
was
but-
mentioned earlier, we could have an accelerator if we really wanted to.
Yeah.
Okay.
Then we get to iShiftable. Now, notably, this has two C# language relaxations or changes. One, it's going to lift the restriction that the right-hand side must be int.
Yay.
It is now allowed to be t_other. In practice, this will end up being the same as t_self, and it will still follow the same restrictions. So, long shifted by long is well defined, provided that long is within 0 to 63, and C# will, for long right shifted by long, still mask it as appropriate. But it's convenient for cases where you're doing things like trailing zero count or leading zero count, where the result is t_self, and you don't want to have to cast int.
So is the language also introducing a logical right shift operator?
Yes, that is the other change, is that there will likely be an explicit logical right shift or unsigned right shift operator.
Yeah,
And it will involve a new ECMA name.
I was gonna say
Or no, this one has the ECMA name.
Yeah, so apparently we have ECMA names for these operators, but C# operator overloading didn't define it, and I was like, wait,
Excellent.
I'm at a not applicable in this table.
Yeah, and it will likely, the current proposal is to just use the same operator as Java and basically every other language, which is just triple greater than bracket.
Sure. Okay, so two follow-up questions then. First, do we need an explicit sign shift operator? And second, do we need an explicit barrel shift operator?
You mean rotate?
Rotate, yeah.
Yeah. Both of those are out of scope.
Okay.
So for sign shift, we, just like with the checked versus unchecked, we believe that the current right shift will, for sign types, is already a signed right shift. And for unsigned types, it doesn't matter. And no language actually defines a signed right shift operator anyways. And so we think that just right shift and an explicit unsigned right shift will be sufficient here.
Got it. So you're saying that the, like, air quotes default right shift for a signed integer will itself just be signed.
Right, but it's
Okay.
not going to change its name or anything like that. And if you really want it to be unsigned for whatever reason, you could do that.
Okay, that all sounds reasonable.
Well, but if I shift operators is defining this, and we say that it should represent the unsigned right shift, this means we're gonna have to define this on int, and then we're just gonna go against convention, and it's gonna be the signed right shift.
No, it's on int. It will be the unsigned, and C# will implement it as unsigned.
But I thought currently we had a signed shift.
Yes, which is 2 brackets.
Oh, we don't have the 3 right arrow at all.
Yeah, we don't have 3 right arrow at all. That's completely new to C#.
All right.
Assuming that they approve and actually implement and don't change what the token sequence is for it.
Right. Okay.
So does that make sense to define on all types though? You want to support shifting?
Basically, anything that supports shifting will have left shift. It will have a right shift, which is typically signed or unsigned based on what the underlying type is. Like for big integer, it's currently signed.
Because the 2 greater than is as signed as you are, and triple greater than is unsigned.
Right. And today in C#, if you have an int and you want to do unsigned right shift, you end up having to convert to uint, do the shift, and then convert back.
Yeah.
And that's possible when you know the type definitively, because you know the corresponding unsigned type. But when you get something like big integer or an arbitrary t, you don't know if there even is a corresponding unsigned type to convert to. And so short of exposing a unsigned right shift named method, this is the proposal to cover that scenario. And it will also simplify existing code using primitives that's not even using statics and interfaces, because you'll no longer have to convert to uint first.
I guess worst case, I just implement the triple right shift the same way and I implement the double right shift, right? So if I do the IO stream madness from C++, I would just say, yeah, right shift is basically an out in the same way that a double right shift would have done.
Right.
Do we also need, oh man, I just completely blanked on what I was going to ask. I'll get back to you.
Okay.
Good morning, Levi.
Good morning, everyone.
We then get to min-max value. This isn't necessarily the best name, but it's the name that describes what it represents, which is that the type has a minimum and maximum value. It is not a concept unlike iNumber, because things like big integer do not have a min and max value. But also things like date time do have a min and max value and are not themselves numbers.
Oh god, I was about to ask, do we have yeah, I guess you just answered the question.
Yeah, when we added date, did we give it both, or sorry, date only, or whatever we called it? Did we? I know we gave it I think we gave it the min value. Did we also give it a max?
I thought we did, no?
We have a min day number. Oh, yeah, min value and max value.
Okay, we did add them as the pair.
I don't think I've seen any place where we've only exposed one.
I mean, if the type has a minimum, it ought to have a maximum, right?
I mean, if you had unsigned big integer that you were willing to let it go until the GC ran out of memory, then it would have a 0 min value and wouldn't have a concept of a maximum value.
I guess.
It seems a little odd, but yeah.
Yeah, and so, I think that's the kind of case where you wouldn't want to necessarily expose min value and max value there. You just say there is no bounds, and you'd say that it's an unsigned value, so therefore it's you'd say it's an unsigned number, and therefore implicitly 0.
Yeah. So we now have the min-max value and the additive identity, I think, which are the two things that are not operators.
And multiplicative identity.
I don't remember seeing that one. Oh, here it is.
It's there, yeah. Do we also need like a 0 here too? 0 might be distinct from additive identity.
Number. That's on number.
Got it.
Right. So then so we came up with an I purpose operators for the operators. Like,
I has multiplicative identity. I has min-max value.
Only if has is spelled with a Z. Yes.
Right. So is this, yeah. So it's what do we think we want to call these things? Do we have a I thingy value holder is the thing that popped into my head first, but I don't really like it. Yeah. But it's a start of a discussion.
Yeah, and I didn't really have good names for them, so I kind of just went with what's the property they're exposing and say it's I that.
So the one thing we have to keep in mind is that the way the proposal works is that pretty much all the primitive types will implement them, right?
Right. And for something like min-max value, it will have to be explicitly implemented because constants with the same names today.
Yeah, I care less about that. It's more like if you look at the definition of int32, right, we should make sure that when somebody who's starting to learn C# looks at those names, their eyes are not rolling to the back of their heads, so the names at least somewhat make sense to people, right? And they know, oh yeah, that just makes it plusable and minusable and whatever, right? So like we should pick names that are somewhat reasonable.
And that's kind of why I went with like I-addable, because anyone who's taken 3rd grade math will understand I-addable. And despite what Twitter says about I-monoid, we're not doing I-monoid.
No, we're not doing I-monoid.
And I mean, if we do I-addable operators or I-addition operators, I think that will be also trivially understood by beginners. And
yeah, I agree.
I think like I min max value will be trivially understood or understandable as well.
Yeah, what Jeremy has there right now, I like, because basically, if we get rid of the UBL, like if we get to uniform convention, we just say IXXX operators. I think that's fine.
Yeah.
Mm-hmm.
Yes, with the bitwise being we went with a group concept instead of picking a name.
Given your I equality operators, would it be I comparison operators as well?
Yeah.
Yeah, we can go with that instead of inequality. Yeah, I hadn't.
And I would probably
remembered
should
to write
always
that
use
down.
the plural, even if it's just a single operator, because
Yeah,
maybe we gain one in the future.
And
Yeah,
there's
consistency.
checked and unchecked variants, so it is kind of is.
Yeah, that's true too.
Were there we didn't go over conversion operators. Are those like somewhere else in the proposal?
So conversions are this concept that are briefly touched on below, but they are very hard to define here because they are very kind of exponential, particularly with primitive types.
Yeah, because I know that the canonical way to do this is to just implement iConvertible, and then, well, now you have, two whatever APIs.
Yeah.
But that's, like you said, it is a lot of work, and it doesn't allow for more power scenarios. Like, I want an unsigned version of whatever integer type I happen to be using.
Yep.
Stuff like that. And at that point, we're getting into something akin to like C++ type traits, which I think you already said was out of scope. But it is nonetheless very compelling to be able to say, I don't know what width this incoming integral type is, but I really want an unsigned version of it. Because I'm going to start doing checked arithmetic operations against the unsigned values, for instance.
Mm-hmm. Yeah, and that's some of the concept that I've got annotations on further down. So the group we've just finished is effectively the core interfaces. They're the interfaces that allow everyone else to build upon them. The expectation is that most users probably won't actually use them unless they're defining their own types. Unless they're defining their own interface types that build on top of them. And so once we start looking at like iNumber, we'll start seeing things like here's how you create a number from other numbers and conversions and things like that. And it may be that we do want something like iConvertible or iConvertible to and iConvertible from. Okay. But I've not exactly finished the prep work on those and investigatory work just because even with something like int, you end up having like a minimum of 10 conversions plus the convert to any other type conversion.
Oh yeah, this is going to turn into a lot of work under the covers. Like hopefully most of this no one will ever see, right? As far as a typical consumer goes.
Yeah.
So, did anyone want to... I have a note for the 3 that we have so far of what renames to apply, but maybe we're actually okay with the names, or maybe nobody has a good thought right now and we can move on, but it does
there was some
feel like these stand out.
There was some discussion that I had on Discord, and there's suggestions like I fixed range value and variants like that, and I think min-max value is it's not the best name, but it's short, descriptive, and covers what's exposed.
I actually do think it's the best name because if you look at it, you know exactly what it's for. I mean, it really isn't much more of a mystery here, right?
Okay, I mean, like this is just it is a new kind of interface. Our existing instance interfaces, we like the ables. We said for the operators, we want them to end in operators, and then this one is I'm exposing a static property, and so is it that we think that it's what are you doing value is the formula we want?
So
I mean, that's fair, right? It's
because additive identity was just called additive identity.
Right, because it doesn't...
Otherwise, we're saying it's the primary properties name.
Right, and I went with primary properties name, so I additive identity exposes additive identity. I min-max value exposes min value and max value.
Yeah, and maybe the answer is there's not a good... Like the primary property or properties is the best answer, and we don't have a good thing. I'm just asking. We have 3 of them here. Can we come up with consistent naming for them? And
Regarding the user experience, so say the current plan is to ship these in 6 in a preview state, correct? But we still need types like int32 to implement these interfaces, correct?
Yeah.
Is the idea that if I have not opted into preview language and runtime features, like I don't even see these interfaces, they don't show up in IntelliSense and so on?
Yeah, and we're going to have to do
Okay.
some special work with once we get further down to like floating point. Single will likely expose a new ACOS method, in which case, due to the difference between what's exposed through the interface and what is already exposed on the type, we will have to explicitly also annotate those methods as preview, because they won't go through the interface.
Yeah. Okay.
But to answer Levi's question, I mean, like the general idea with preview features is that, types or members might be marked with preview, but there is no plan to restrict IntelliSense. Basically, the idea is you are always able to see those preview features, and then when you start using them, then you might get a warning because you haven't opted into them, but there is no attempt to hide them because, well, we want people to discover them and play with them, right?
I see. I guess the thing that was making me nervous here is we're talking about changing like fundamental exchange types in the runtime.
Yes.
For the overwhelming majority of people who will not have enabled preview features and won't care about them.
Right.
Yeah,
And
I think I'm more nervous about members that show up because, I mean, if a type implements 12 more interfaces, you don't discover that in IntelliSense, right? Normally, the way you discover that they do is by them exposing more members, right? But if they're all explicit, then it doesn't matter. But some of the things will be, visible, right? Like we will have in.min, right, or in.max, right? And so there's some new things that will show up, but I mean, I don't know, like that to me is kind of also the kind of thing you want to usability test, right? So like if we, end up, adding, I don't know, 20 more members to N32, let's say, well, during the preview time, you would like to get feedback from people that look at this and say like, oh, that's odd, right? And so
yeah, int.additive identity, int.multiplicative identity will just kind of start showing up.
Yeah, I guess that's going to be
int.0. Yeah.
But I mean, honestly, like I think at this point it's also fine, right? I mean, I think at the very beginning when they did the framework, I think there's a part in the book where they tried to minimize members on int because people felt the more members there are, the more heavyweight, the primitive fields. But like we have structs in it. People know how structs work, and whether this thing has 100 or 50 makes no difference, right?
Yeah. Okay.
I mean, there's also the, int.additive identity can be EB never and or an explicit implementation. Like,
right. You could do that too.
We can conform to an interface without making IntelliSense be noisy.
Okay, yeah, just as long as the user experience is good for people who have not opted into preview features, and I think like my concern there is alleviated then.
Well, I mean, I think honestly that's the wrong way to do it because I think the way to think about this, eventually the feature will be stable, right? And so that means if we design the feature, we have to design it with the assumption that everybody is opted into that, right? Because eventually everybody will be opted into that. So we need to design for that case, not for the 6 to 12 months where 5 people in the world care about the feature.
I guess maybe I misunderstood who the feature was intended for because I assumed that this feature was intended for developers who are writing libraries which take mathy types as their T. Like if I'm using a concrete type like int, long, whatever, I generally don't care, I believe, about the APIs being introduced here.
Right.
No, I think that's
true.
Like my point is just that eventually, like in .NET 7, let's say, when the feature is stable, everybody is opted into C# understands this thing now, right? And so people will still be in this bucket that as you said, the vast majority of people doesn't care about operators, right? They just want to parse an int or, compare it or whatever, right? And so the user experience we have to design for is that if I'm not a class library author that does math optimizations all day long, do the core types now feel more complicated, right? And the answer hopefully is no, right? And so that's why I'm saying I would not scope it preview, non-preview. I would just say, once the feature is stable, does the ordinary developers, are they still able to use our primitives, or are we now overwhelming them with 500 concepts, right?
Yeah, and in many cases, users won't particularly for the core operators we just looked at, users will never see them. They
Right.
min value and max value already exist. Additive identity will be new, but it will probably be explicit. That's not something you really care about outside of the interface itself. Now, 1 and 0 will probably have to consider, is this worth publicly exposing, or should it be explicit? Likewise for operations like absolute, clamp, divrem, and things like that, we'll have to decide, should these be explicit or are they worth exposing?
Right.
And users will likely end up using those things, and they are likely useful even for users who aren't doing generic math. And whether they're public and implicit or private and explicit will likely come down to how usable do we want it to by other users, by non-generic users.
Yeah, but I'm hoping
I
emo
also-
with all experimental features, which this may be the only one, but that you're chatting with the IntelliSense people, and if something has the whatever attribute we end up putting on, this is part of an experimental feature that counts as EB never if you haven't opted into experiments and is full if it. Because I thought the whole point is we think that we may end up changing the signatures on those methods, so you don't want to depend on them. Like,
No, but that's the whole point of the feature is to make it discoverable, right?
Okay.
So like, I mean, it's all fine to see signatures that might change, right? What
Okay.
really matters is once you start calling them, and then our analyzer will tell you like, sorry, you're not opted into the preview, right?
fair enough.
That's what I'm saying. To me, there's no point in. I mean, Jan asked the same question, but I mean, to me, the whole point of preview features to ship them in RTM products is to increase usage, right? And so, if you don't advertise, you don't increase your usage, right? So you want to advertise, you want it in people's faces like it's a regular API. And
Okay.
when they start using it, that's when our enforcement will kick in and say, sorry, you need to opt into this, right?
Okay. I'll trust you for the UX part.
I mean, I'm asserting this. I mean, this is all new, but I mean, to me, it would be very weird to go out of our way to hide it from IntelliSense because, well, if you want users, that seems going the wrong direction.
So for this, so the like I've said a couple times, the previous was the effectively core interfaces used to build everything else. Here's from here on is the actual what I've called the numeric interfaces, the interfaces that most users who are doing constraints on generic types will likely interact with. And the first of which is iNumber. And like I mentioned when Jeremy asked about complex at the beginning, this is more like a singular number. And so something like a complex, which is realistically two numbers put together to represent the conceptual whole number. Two parts rather. Those would not be covered by this interface, and so we may want a better name like iScalar.
I was gonna say, do we want scalar? Do we want simple number? What's a thing that is both explainable and not overreaching? Because number feels overreaching to me because of complex.
Yeah, it's worth noting that other languages like Swift just use number or iNumeric or similar here, and they basically say for the purposes of what programmers think of as a number and not what mathematicians think of as a number.
I ring.
that number is explanatory enough, and it's simple enough to explain to users. This doesn't cover things like complex, which are represented by two parts, and you want something else to represent that instead.
I mean, I actually kind of like iNumber. Like, I assume you would say that most people who write like code that wants to be, templated over, let's say, ins and floats and doubles would just talk in terms of iNumber then?
Yes, iNumber or potentially iBinary number, but realistically it'd be one of those two types, depending on what you're trying to do.
Yeah, I mean, I number might not be the correct term, but it's probably the one that intuitively would at least make close to the most sense, right?
Yeah. And in particular, scalar is not a name that most users end up encountering.
Yeah.
And so I'd rather differentiate between iNumber and something else for things like complex.
Yeah, I just like it fails my like I'm it's not strong pushback, but it fails my English test of I complex number or complex number is a number. Like that is an English sentence that makes sense, so it feels like the code tree should say that's true, but we would be saying complex number is not a number.
Right.
It's not a number. It's just not a number.
It's not an I number.
Right. And
Yeah.
and maybe that's fine. It's just
and I think the number of users that actually use system numerics complex is greatly less than those that are going to look for iNumber when they're working with like integers and stuff. But if we do come up with a better name, I am very much open to that here.
I mean, who would implement this? Basically, like the primitive
right. So
integers and floating point values, right?
Yeah. So that's the
integer and all of that.
That's the section after this section, which is
Okay.
the implementers. And so this one's not directly implemented by anyone. It's actually the interfaces below this that are implemented by the other types. But almost all of the primitive types, short of date time, time span, and GUID, do implement iNumber.
Is complex listed there as well? What is implement?
No, complex is one of the types I have listed as pending concepts.
Okay.
In particular, it can't implement iNumber because it has two parts, and so there's not a good way to represent it as there's not necessarily a good way to represent it as a number, given it's got both a real and imaginary part, and given that not all operations we've put on number are valid for complex.
Yeah, I mean that to me is kind of the sticking point in terms of interfaces that we should think through. Same with vectors, right? Like I think that's kind of the litmus test for most abstractions is like, is it too broad or too narrow? As in like, how much does the consuming or producing code suck? So that seems like something that we should look into. Because I mean, my math skills are also not up for the job.
For vector in particular, there is an interface that I pushed up this morning, and there's an open question of should t-scalar simply be restricted to where t-scalar is iNumber and appropriate other interfaces, or should it be its own interface that itself inherits from iNumber? And I'm thinking it should be an iScalar, where iScalar is a number. But that's kind of still open.
I felt a very Charlie Brown moment because I heard literally wah, 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 wah. iScalar is a number, and I'm like, wait, what? So hopefully it made sense.
So this implements basically all the interfaces we just defined, short of a couple that are further down. Like this doesn't implement bitwise operators because not all numbers are bitwise operatable. That really only makes sense for binary numbers and not, for example, decimal numbers. It then exposes a couple additional concepts here, namely the create methods. In particular, there's a lot of concern over implementing them because it's not really trivial to take an arbitrary t other and to create a t self from it.
Can you explain to me what t other is in this context again? Like t self is going to be int as opposed to maybe implemented over int, right?
So then t other would be byte.
Yeah, so t other is some other iNumber, which in most scenarios is probably something like an integer literal or a floating point literal. And there's actually four concepts exposed here. There's create from T other, which will throw if T self is not representable.
So these are effectively numeric conversions then? Is that the way to think about them?
Yes. There's create exactly, which will return a nullable. It's effectively the try create. But in particular, it's not try create because it throws if the value is not exact. It returns null if the value is not exactly representable.
I see. So that's when you go from, let's say, float to decimal or something.
Yeah, let's say you're going from float to int, and you want to know that the value is exactly representable, and you're not losing any precision. There's likewise create saturating for the value is too large, and you just want to saturate to max value, and create truncating, which is explicitly, I want to create this while dropping the dropping any fractional portion.
So this is downcasting or unchecked downcast long to int.
Right, and create is effectively the checked cast, which is the default. And in most scenarios, that should hopefully be optimizable away. This is likely one of the places where if you're implementing a type, you still have to use the generic if type of T equals type of U. And in the worst case, you might get an I number that you have no clue how to handle, in which case you might have to throw and say, I don't support creating this.
Yeah.
But
So
in the common scenario, this will likely be coming from some primitive or recognizable value, or something that you can check, like I'm a binary integer, and so I can just get the binary representation and understand the bit pattern. So it might be expensive in the worst case, but likely doable. And it's really only for arbitrary numbers where you might have to throw.
this is, yeah, but it feels like we are creating this as a generic because we have to, but it's inherently a type of all. Like there may be some mild exceptions, but effectively it's a closed generic that looks open for any particular type.
Yeah. And it's fairly open still in that most users will likely be something like a binary integer or a binary floating point, and so you'll be able to do the right thing with them. But there may also be something like someone defined their own type that's a number, and you've got no clue how to convert from that. And Stephen Tobe suggested maybe we want to have the inverse represented as well, like cast to, in addition to effectively this create from. But you kind of run into the same issues there and potentially recursiveness problems. And so it needs a little bit more thought on and scenarios written on how this is going to work. And part of it's waiting for the runtime to provide something for me to work with here.
But it is kind of the problem of, like, look at iConvertible that also did both directions, and very often you need the other direction in order to do it, right? Or take normal implicit conversions or explicit conversions where I want to implement something that interoperates with a type that I don't own. So the only thing I can do is I can define operators on me. That's why C# allows them to be defined on either side, right? But like, if you only allow one side, that basically means that anybody who wants to extend I number basically has to be known by us or go through the interfaces that we already defined. So if you literally create your own out of thin air, then it will probably not be able to interoperate at all with us, right?
Yeah.
Right, and that's where a cast to or iConvertible to like thing will help. And it may be that we end up having iConvertible from, which takes these, and iConvertible to, which is basically the inverse of these.
Yeah, and I wonder, like, does this really belong at the method level, or should this be at the type level? So int can say that it's convertible from only I bitwise others, and that not that we've seen that yet, but that if there's a way that I bitwise other supports understanding like here's a read-only span of the bit pattern, go, then it'd be like, fine, if you can give me a span of what your bit patterns are, I know how to create a 32-bit truncated version of that. And so then it's that way we don't end up with, well, I'm of any number, well, but I don't understand this number, so no. And it's very clearly in the type hierarchy. It says, here are the rules for when this will work.
Yeah, and in particular, we have to be careful here about number of interfaces we expose, because if we're conversions is the place where it really explodes. Like, we have a lot of interfaces so far, but if we start exposing like one per valid conversion, we will not be able to ship this feature.
Because int will say that it conforms to too many interfaces?
Right. We'd end up having like one for byte, s byte, short, u short, int, un.
Right. I mean, we could collapse that for the primitive numbers by making one that says you have to define all 100 members of the
you could
types times
define
the 4.
an
But
I expressible by integer primitive and I expressible by floating primitive, but
because looking at the like a couple things are weird. One, it feels weird that this is on number, and that maybe it should be carved off. And two, it feels like you kind of always need to have the same other support across the 4, and that seems like it's really only convention. Like it's a convention-driven thing because nothing can help enforce it once it's 4 independently generic methods.
right, and that's kind of this is how Swift exposes it effectively, and they effectively expose it on number. But this is probably the thing that we're going to end up having to do the most work on, in most iteration on, after I get a prototype that allows me to start, testing the actual scenarios and not just writing them and saying this should probably run.
But so if we look at complex number as a thing that is a number but isn't a number, would these operations also make sense on that? In which case, does this need to be, or would it be a lower level interface than number?
Right, and I think that's where the I convertible from and I convertible to kind of come into play if we need them. And there might be some pattern we tell users is like, this is how you should implement it, so that you say like I convertible from is the main, and if that fails, try I convertible to via check, and it effectively becomes like dispose pattern where there's a recommended way to do it to be correct, and if you're not careful, you can like end up in infinite recursion land.
I mean, realistically, what it boils down to is we need to write generic code, right? You need to be able to, and that's you kind of have to write substantial amount to actually see what works. It's the same problem we had with vector of t. Until we actually had people writing code against it, things look sound on the board, but then when you actually take arguments, you realize that certain combinations just don't make sense, right? And it might be the same here, right? Where if you actually, as Jeremy suggested, if everybody deals with I number, then it's fine. But if say, I break out into the more specific interfaces because I implement, I have these weird types that aren't numbers, we now have glaring holes where, well, you can't get into that generic space because you don't have these methods, right? And that's, I think that's kind of the problem with some of the stuff. I think Steven at some point tried to implement like averaging over link with some proposed language syntax, and he couldn't get it to a point where it would actually do anything useful. And that's kind of the concern, right?
Yep, this is probably the most critical set of methods, and that's why I was saying I think it's probably going to have the most iterative work, because this is effectively how you convert from one T to another T.
Right.
Moving past those though, there's some open questions over like, should we have is signed or is binary or is fixed width or the base or radix? Other languages expose some of these. They might be beneficial. I've not done a lot of investigating there yet. You also get into the named value 1 and 0, which are effectively aliases for multiplicative and additive identity.
Mm-hmm.
And then you get into some of the things that Levi asked about earlier, like absolute value, clamp, div rem, max min, sign. Sign is notably exposed here on number, even though for unsigned values it will only ever return 0 or 1, because I think that's more convenient. Likewise, there's a question of should negatable be on here. When we start looking at vector of t exposes negation for all types, not just sign types. Likewise, when you start there's a similar thing for the bitwise operators, where vector types expose it and it's well defined for floating point types, but where C# doesn't allow you to do float and float today, even though it's logically a sound operation.
So these apps, clamp, and all of that, like that seems like becomes a grab bag of functionality that will grow over releases, right?
Right. It basic, especially when we look at floating point, it basically means that math and mathf might be dead.
Well, that one is fine, but like, didn't you say earlier something along the lines of we don't know whether we can get DIMMs to support? Because if these things will not be dimmable, then we kind of screw.
We don't know if they're dimmable in V1. We said that they'll be required in V2 when we look at adding additional functions onto the interfaces.
Where V2 is really the full product, right? Like V1, you mean the experimental feature that's going in .NET 6, and V2 you mean .NET 7 when we think it's done.
Possibly. Or it might be V2 as in actual V2.
Like
but
.NET 8, basically.
yeah, but that's something that we'll have to work with the C# language team on to make sure that they solve the. There was a couple open questions about DIMMs due to how they're implemented and exposed, and how you can't actually defer to a DIMM implementation today. Like if you want to override a DIMM, you can't override it by forwarding to the actual DIMM.
Right.
And so they need to fix that for this scenario for DIMMs to work. And
like if you wanted to add a check before dispatching to the...
Right. Or if you want it to be implicitly implemented rather than explicitly, because by default DIMMs are explicitly implemented. And so the language team has to work through those couple remaining issues before they say that DIMMs are ready here.
Gotcha.
So, but you are saying they are committed to make it work in general. They just don't know the timeline, because if we find ourselves in the future where we just can't support DIMMs, then that direction seems somewhat scary, because it means we have support for like 4 core methods, and the rest is now at best generic methods with a switch statement in it or something, right?
Right. It means that we have I_2, I_3, I_4, which is why we told C# in the runtime DIMMs will be required for by the time we decide to expose new methods on these interfaces.
Right.
We've expressed to them so far that is a hard requirement, because we do not want to ship I_2, 3, 4, etc.
Well, it's not so much we don't want, right? I mean, like, I don't even know how it would work.
All right. So I have some commitments today. I can keep the stream running for 5.5 more minutes, and then I have to shut it down. So
we should be, if we go quickly, we should be able to get through the rest of this section at least.
Okay.
So then because most of these next interfaces are actually fairly empty. iSign number is a number that is also negatable. Like I mentioned, negation we might want to move that onto iNumber itself and define it as 0 minus value. Particularly when you look at vector and stuff, we actually define that today already. iSign number is very important, so that way you can differentiate on whether the value you're operating with is signed or unsigned. It allows you to do the appropriate constraint. Then we have binary number, which is a number that also exposes the bitwise operators. It also exposes a few core concepts like isPow2, log2, which we currently expose on system numerics bit operations. It also exposes some concepts from big integer, which are get bit length, get byte count, 2-byte array, and try write bytes. I'm not convinced these are the right signatures. They're currently copied verbatim for big integer. I think we want to change them slightly.
Yeah, adding that
improve
is
them.
there is one of my biggest regrets.
Um,
That was my bad.
So I think we want to fix it, but we do want some concept to say for a binary number, you know if it's signed or unsigned, and you can get the raw bit representation. And this is what allows you to, in create, say, if t other is a binary number, then I can always get, the bit representation and understand it. Then you've got ibinary integer below that, which exposes the shiftable operators on top of it, as well as some things like leading zero count, pop count. Pop count and leading zero count might be better on binary number, but they're really focused around integral values. And then rotate left and right, which Levi asked about earlier.
Yeah, and you chose to keep the rotation amount an int here instead of a t self because
I forgot to update that one.
okay.
We likely
quick
wiped
question.
both int and t self.
So what is not a binary number then?
Decimal is not a binary number. The IEEE decimal types are not binary numbers. They are decimal numbers, and you cannot interpret them as a bitwise value. You cannot perform bitwise operations like OR and AND on them.
So it's basically the definition of a binary number, like a number that is like represented contiguously in memory as bits.
Yeah, it's a binary representation of a value. So it's based on a base 2 radix.
Oh, I see. So like a short would be, an int would be,
Yeah.
a char would be, but
A
instead
decimal
big decimal wouldn't be. Yeah.
The next key concept here is floating point. This is probably the method that's the interface that's the biggest. In particular, decimal is not a floating point. Decimal is a Microsoft-defined type that's actually not standardized.
Well, it's also basically a fixed point, right?
Right.
Yeah.
And
That's what I say.
and it doesn't support most concepts like infinities or nans or cosine or any of the operations. It's really a currency type, and it's meant for use in currency. And even though there's like 29 significant digits that you can have on the left or right side of the decimal point, realistically you don't want the number of digits to go over like 10, or the perf tanks terribly. And so decimal is explicitly not a floating point. It's its own thing.
Again, it makes sense to me from your name. If it's not floating,
Yeah.
it's fixed. If we had more than one, then we would probably define the fixed point.
Well,
if we had a
it
reason.
is floating in that the point can float between the 29 significant digits that are representable, but it's not the floating point in the way that I think we should be enforcing it, which is the IEEE floating point types. We could have iFloating point and IEEE floating point, but I don't think that's worthwhile. But it basically exposes the constants, all of the methods off math that we've approved, and then I basically list the IEEE requirements. And then we get down to ibinary floating point after that, and idecimal floating point, which I've defined for the IEEE type, but we won't actually implement it if we never expose decimal types in the future. And then the last interface in this core set is iVector, which effectively exposes the vector of t interface. It's the same interface I've suggested we expose on vector 64, 128, and 256, but we've not reviewed yet. And it would also be implemented by vector 234. It could be implemented by generic math vector types, and it effectively allows you to take a set of values. For example, Python actually represents their arrays as effectively iVector here, and you can add two arrays together in Python, and most other languages that support traits like this. Not saying that we will implement array as iVector, but it's an interface that allows you to effectively fulfill that contract. And then there's an open question here on should tscaler be just a generic type that's constrained to the above interfaces like iNumber, or should it be its own interface that implements those? And I'm leaning towards the latter because I think that will be more future-proof. And
Yeah.
then
I mean, I think we'll probably want to talk about that when we're a little less info saturated.
Yeah. And time constrained.
Yeah.
But then the next section is just the actual interfaces, or the core types and the interfaces they implement, both the ones I've defined above and the ones they already implement, like iSerializable. So you'll see like time span implements multipliable and multiplicative identity and things like that.
So what are the next steps for the feature? Like, I mean, should we just set up another round of going over the remaining details, or like what is the next thing
I think we want to go drill down a little bit more into the concepts we kind of skimmed over just here. Particularly with floating point. I probably want to fix up based on the feedback we've had so far. And hopefully by the time we do the next review, they'll actually be the runtime prototype will be ready, at least for me to do things locally. And I'll be able to provide some actual scenarios for us to like walk through and see how important concepts like create.
Okay, so here are the notes that I have. I guess for the value exposing interfaces, maybe they're good. Okay. Yeah, so people should try and think in the back of their heads on the value exposing interfaces of can we come up, is this the pattern we want, or is there a better one? And then basically I have that we kind of stopped at a binary number.
Yeah.
Tanner, the additive identity, multiplicative identity, min-max value, is there anything that should be added to that list as far as value exposing? Like, is that complete?
I think that's kind of complete right now. Okay. The other constants are more restricted to like floating point or binary numbers where you can actually say things like this has a significant and an exponent. And they're not really generic in that sense. It may be that as we, look more at complex and maybe other libraries like math.net, they may have concepts that are important for us to expose as core types as well. But at least today I don't have those.
All right. Since nobody else is commenting on my comments, I will post that. And Emo, I'll let you take care of the email stuff because I gotta go.
Yep.
So.
Awesome.
All right, then. Thanks everyone, and then I think we will flip it back to needs work, and then whenever Tanner is ready, we can take another look.
Yep. There's actually, I don't think, a label on it today, is there? Oh, there is. Okay.
I put it on it.
Yeah. Otherwise, it wouldn't show up in the things I can click on.
Exactly.
All right.
All right. Sounds good. Thanks everyone.
Bye, Internet.